Hi and welcome to the 6th year higher level maths revision video where we're working with revision worksheet 10, which was a mixed revision worksheet. Question 1 was a calculus question worth 25 marks. Part A, differentiate 5 minus 3x minus 2x squared with respect to x from first principles. Now, first principles has a very specific layout, so it's really important that you follow it. The first thing I would suggest that you do is actually use your shortcut to differentiate this so you know what the answer should be. So here, 5 disappears, minus 3x differentiates to minus 3, and for the last part, remember, bring down the power and take 1 away from your power. So you're left with minus 3 minus 4x, and that's what our answer should be. You need to know the formula for first principles off by heart. This is it here. F dash of x, so the derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. We're going to take this one step at a time and work it through. First thing I'd suggest you do is to work out f of x plus h. That means if we take the original function, which they didn't write in function form, but we can always do that, 5 minus 3x minus 2x squared. Everywhere there was an x, we are now putting in an x plus h. So here's our x and our x. Now we're putting in an x plus h. This is then what it looks like. So 5 minus 3x plus h minus 2x plus h squared. I would expand and simplify. So here's expanding the first bracket, 5 minus 3x minus 3h minus 2 times, square the bracket. Remember, following your BIMDAS, we always square before we multiply in. Squaring that bracket, x squared plus 2hx plus h squared, and then multiply out. So our answer is 5 minus 3x minus 3h minus 2x squared minus 4hx minus 2h squared. It can't be simplified because although there are two x terms, one is a hx term and one is just an x term. So that is as simple as it can go. So we've just worked out f of x plus h. Now we're going to do the whole top line, which is f of x plus h, take away f of x. So when you do this, make sure to use your bracket to show the subtraction. It's really important that that minus affects the whole function. So it's minus the whole function f of x. When you multiply that out, all the signs will change. So we have what we had for f of x plus h, then minus 5 plus 3x plus 2x squared. There's a really quick way to check if you're right, and that is, do all the f of x terms cancel with something that's already there? So what I mean by that is the minus 5 cancels with the plus 5. The plus 3x cancels with the minus 3x, and the plus 2x squared cancels with the minus 2x squared. That's not a coincidence. That should always happen. So if these terms don't all cancel, then something's probably gone wrong with your sign. That leaves us with minus 3h minus 4hx minus 2h squared. Step 3 is then we're going to look at the full fraction. So f of x plus h minus fx over h. So really that's a division by h. You can think of this as divide every term by h, or you can do it using some factorization. So if we use factorization, I'm going to pull out a h that's common. I'm left with minus 3 minus 4x minus 2h all over h, and then the h's cancel, and this is what we're left with. Some people like using that factorization. It's the clearest way to see it. Or again, you can think of it as dividing each term individually by h. The last step then is to put in the limit. So the limit of what we've just worked out. So the limit as h goes to 0 of minus 3 minus 4x minus 2h. There's 3 ways to work with limits, but for this one, we're using the easiest method, and that is where we just sub in, okay? We're saying instead of h, we're subbing in 0. Now, when we do that, the limit will disappear. So what this turns into is simply minus 3 minus 4x minus 2 times 0. So when you do the substitution, the limit piece is used. The limit as h goes to 0, that's saying put in 0 for h. When you've done that, this part disappears. So we're left with minus 3 minus 4x, which is our final answer. Double check that that's what we had when we did the shortcut. It was, so all is good. So B, the equation of a curve is y equals ax cubed plus bx squared plus cx plus d, where a, b, c, and d are elements of z, which means they're integers, so positive or negative whole numbers, and x is an element of the real numbers. The coordinates of a turning point of a curve are 0, 2, and the coordinates of a point of inflection are 1, minus 1. So we've been given two important pieces of information. We have a turning point and a point of inflection, and they're asking us to find the values of A, B, C, and D. So just some key points here. To get turning points, we do the first derivative and we let it equal 0 to solve for x. To get a point of inflection, we have the second derivative equal to 0. And then the third thing is, if we have a point, and remember, even though this one is a turning point and the other one is a point of inflection, they're both just points that are on the function. When they're subbed into the equation, they'll work. And what I mean by that is the equation will balance. So we can use that fact, and that is 4 different pieces of information then that we have. So I'm going to work with, first of all, the point 0, 2. I'm going to work with this not as a turning point, but just as a point on the curve itself. So this is a cubic, and we don't know whether it's positive or negative. We need to understand first what the value of A is. However, I do know the point 0, 2 is on it. Now 0, 2 is a very special point because that's the point that's on the y-axis. So that actually tells us straight away the y-intercept, but that then links to the constant in the cubic. Now, if you didn't see that, what we could do is substitute in. So instead of y, we put in 2. A x cubed plus b x squared plus c times x plus d. All those zeros disappear and we get d equals 2. So the constant, the one without an x, so the d, that is 2. So 0, 2 because that's the y-intercept. Now I'm going to use the turning point. Now, for the turning point, we need the first derivative. So the first derivative is going to be dy dx. So we're going to differentiate this. You bring down your power and take 1 away from your power. Bring down your power, take 1 away from your power. Bring down your power, take 1 away from your power. So when we have anything that's just an x term, it ends up as the coefficient and constants disappear. For this turning point, we would have let this equal 0. Okay, so that's how we get a turning point. The first derivative, I've written it as f dash of x, but you can also write that dy dx equals 0. Now, the turning point is 0, 2. So when I sub in the x value, this should work. So it should balance. So we have only the x value. That's all we worry about, okay? We never think of the y value when we're doing turning points. So I have 3a times 0 squared plus 2b times 0 plus c equals 0, and tidying all that up, that gives us simply c equals 0. Okay, so I get my second constant or coefficient here. So I know c is 0 and d is 2. The next thing I'm going to work with is the point of inflection. So the point of inflection is where we take the second derivative and we then let that equal 0. The point of inflection in this question is 1 minus 1. So the first derivative that we had, and I'll just write it here so we can use it, dy dx was 3ax squared plus 2bx plus c. So then to differentiate that again, d squared y dx squared, it's going to be 6ax plus 2b. Point of inflection, I'm letting that equal 0. You need to know that. You need to know how to work with your stationary points, how to say, okay, if I'm asked the point of inflection, what do I do? And that second derivative equal to 0. So now I know that when I sub in the x value from my point of inflection, this will work. So this little equation will work. So 6a times 1 plus 2b equals 0. And cleaning that up, we get 6a plus 2b equals 0. Now, I can't get an answer for that because there's still 2 unknowns. So I'm going to label that equation 1. And I'm going to then try find another equation so I can do simultaneous equations. So the last thing I can do is use the fact that I have this point 1 minus 1 and it sits on the curve. Now to make life easier, what I've done is I've taken my original curve, which was ax cubed plus bx squared plus cx plus d, and I've substituted in what I've already discovered. So remember we found that c was 0 and d was 2. So this simplifies to ax cubed plus bx squared plus 2. So now if I take the point 1 minus 1 and I sub that in with my x and my y value, since that point is on the function, it will balance, it will work. So I get minus 1 equals a times 1 cubed plus b times 1 squared plus 2. Cleaning that up, I get a plus b equals minus 3, and that becomes our second equation. So I have my first equation over here that I had already worked out using that point of inflection with the second derivative. So now I have a plus b equals minus 3. Now it doesn't matter what you want to get rid of first or what you want to eliminate. I'm going to eliminate the b's first, which means I'm going to multiply my second equation by minus 2. So I get 6a plus 2b equals 0. That doesn't change. My second equation becomes minus 2a minus 2b equals 6. The b's then eliminate. I am then left with 4a equals 6, so a ends up being 3 over 2, or if you prefer 1.5. We then take either equation, 1 or 2. I'm going to take 2 because it's a little bit easier. A plus b equals minus 3. A is, I'm going to use fractions, but again, you can use decimals, there's no issue. Minus 3. I'm going to do minus 3, take away the 3 over 2, or take away the 1.5, and then that ends up giving us b is equal to minus 4.5, or minus 9 over 2. Now, the one little issue, and you may have spotted this, is that they did tell us in this question that a, b, c, and d were integers, which obviously they're not. A and b actually end up as fractions. So it would be more correct if this said element of q, which means quotient rational numbers, so it can be a fraction. So just to summarize here at the end, so we have it all on one page, we found that value of a was 1.5, or 3 over 2. The value of b was minus 4.5, so minus 4.5, or if you prefer, minus 9 over 2. C was equal to 0 and D was equal to 2. So just be careful. Again, mock questions, sometimes they go wrong, but we wouldn't expect to see anything like that in an exam situation. This could throw you because when you get to 1.5, you might go, oh, actually, it must be wrong because I didn't get an integer. Part 2 then says hence, so using what we've just done, find the coordinates of the other turning points of the curve. So remember, turning points, we let the first derivative f dash of x or dy dx equal to 0. So here is what the cubic actually looks like if you use fractions, or like this if it's decimal. To get the turning points, we're going to get dy dx. Now, when we differentiate and we bring down the power and take one away from the power, I think it's always much easier if you're working with fractions. But look, if you're happy to work with decimals, do. I just find multiplying the fractions a little bit easier. So bring down the power, so that ends up as 9 over 2, take one away from the power, so that's x squared. And then bring down the power, take one away from the power, that ends up as minus x. That is our derivative because there is no x term and the constant disappears. So we're going to let that equal 0. And when we do, we end up with a quadratic. If you prefer, we can get rid of the fraction by multiplying everything by 2, and then actually you can divide by 9 just to simplify it. Minus 2x equals 0. It isn't a quadratic trinomial, but it is a quadratic because it has an x squared. So we're going to have to factorize. We're going to use highest common factor. X is common, so we end up with 2 answers. X is equal to 0 and x is equal to 2. So the point we already were given in the question was this one here, which was 0, 2. This is our new point. So this is the other turning point. Now they wanted the coordinates, which means the x and the y. So we need now to take this and sub it back in to our original function here to get the y value. So y is equal to 3 over 2 x cubed minus 9 over 2 x squared plus 2. Put that straight into the calculator and we end up with y is minus 4. So therefore the coordinate is 2 minus 4. Make sure to answer the question that you've been asked. It's not enough to just get the x coordinate. They wanted the whole point. Question 2 is a coordinate geometry of the circle question worth 25 marks. So the circle S has a center C, which is at 7 minus 8, and it passes through the point P, which is 2 minus 2. Find the equation of the circle S. I would always say sketch out what you can. It can really help you to understand how to move forward. And don't forget your log tables, page 19 has all the formula you need. So here is my sketch. I have C, which is at 7 minus 8. I've put my point P, I think roughly based off points, it's somewhere up here, 2 minus 2. For the equation of the circle, you need two things. So the first thing you need is the center point, which I have, and the second thing is the length of the radius, which I don't have. But looking at my diagram, actually the radius is just going to be the distance between those 2 points. And that's why a sketch can be so helpful and so important. So x1, y1, x2, y2, we're going to do distance formula. So it's the square root of x2 minus x1 squared plus y2 minus y1, what's your signs, squared. That into the calculator gives square root of 61. I'm going to use the formula that's here to make the equation of the circle because I have my center, which is 7 minus 8. I have the radius, which is 61. You can label the center of the circle, and the center of the circle is labeled HK. And then this is my OR. So my formula is x minus h squared plus y minus k, so what's your sign, squared, equals the radius squared. Let's multiply that out. I suppose no real indication here you have to, but when you're doing this and it's not an exam situation, I'd say, look, expand it, go practice. You wouldn't be penalized here for not expanding it. 14x plus 49 plus y squared plus 16x plus 64 equals 61. Let's clean that up. So we get x squared plus y squared minus 14x. Oh, little typo, apologies. That should be y. Plus 16y, then we have 49 plus 64, take away the 61 from the other side, and we get plus 52 equals 0, and that is the equation of circle S. But if you left it like this and just squared out the right hand side, absolutely perfect. Part II. Q is the point on the circle S that is closest to the x-axis. Find in third form the coordinates of Q. Okay, So this is an interesting question. When it says closest to the x-axis, that implies that it doesn't get to the x-axis. So what we're going to do is we're going to do a really quick sketch. Now, the sketch, it'll be good to kind of get it into the right quadrant at least. So our last sketch didn't have an x and y axis. So although we just had a circle, it was really helpful. Now we want to put in the x and y axis, and we want to get a rough idea of where the circle is. So this is what it looks like. How do we know it's in this quadrant? Well, we're thinking about our points. So think about where that center point is, that 7 minus 8. Think about where that point P was given to us, and that was 2 minus 2. It doesn't matter really about the y-axis, it's really about the x-axis. So it's coming up to the x-axis, but actually it never touches it. So my drawing here is actually taken from GeoGebra, so it is an accurate diagram, but you would just need a general sketch. So it doesn't matter how far away from the x-axis you show your circle. What's important is the circle does not get to the x-axis. So the key idea here and where the sketch comes in helpful is that Q is closest to the x-axis. So when we think of it, we're really looking at a point that is vertically straight up from our center point. So if we draw a line, we will hit our point Q here. So our center point was 7 minus 8. And we know that the radius is 61. So therefore, to figure out the coordinates of Q, we literally move that point up root 61. Now, so root 61, if you want to put it, it's about 7.8. See, then if we think in terms of our y, so our y here is minus 8, and we're adding on that root 61. So the coordinates of Q, it's still 7, the x hasn't changed, but we're going to have minus 8 plus root 61. You can put that into your calculator if you want, but they did say to give it in third form, and it will simplify for you if it can be simplified, but here it can't. So that is our answer for Q. So part B. The point R is also on the circle S. The length of the chord PR is 10 units. The diagram shows R1 and R2, the two possible positions of R. Find the possible equations of PR. Now, the diagram here is really helpful, and there's a key idea that if we draw a radius from C to the end, to the edge of the circle, we can draw one in particular that will perpendicularly bisect the chord. So here, there's its perpendicular bisect, which means if I know the full length of PR is 10, each of these sides are 5, I then can complete the right angle triangle, because remember it's perpendicularly bisecting. So PC is the radius, so in this question it's root 61. And I have my 5, I can work out my third side there. Okay, so that's like just the general idea. We're asked for the equation, and it's the equation of PR. And the equation of PR, which is a line, needs two things. It needs the slope and it needs a point. Now, we have the point because regardless, the point is going to be P, and we were given P earlier in the question. And it was 2 minus 2. So we're going to use that. So we have the point. So really, we're looking for slope. And because of the way that this question is asked with our two possible values of R, we're going to have two possible slopes. Once we have that, we're going to use y minus y1 is equal to m bracket x minus x1. So our slope is our m, and here is the point x1, y1. The two different m's will give me my two different equations. I'm going to keep going and create our general equation which will work for either of those chords. And to do that, I'm going to sub in what I know. I'm going to leave my slope as m since I don't know it, and then I'm going to tidy up to create this like general equation. So it's y plus 2 equals mx minus 2m. It's usually helpful to have it in the form of x plus y plus c equals 0. So I'm going to have mx minus y minus 2 minus 2m equals 0. So that's in the form ax plus by plus c equals 0. So there's my ax, my by, and my c. So it doesn't have an x or a y. So what else can I do? So I've got that general equation, and I suppose now we need to remember the fact that we have this perpendicular distance formula, which is here, and it's the distance between a point and a line. So we have the point C, which is 7 minus 8, and the perpendicular distance will be, if I just get my highlighter, it's going to be this distance here. Now, the same thing is going to happen if we look at the other chord. I'm just focusing in on one rather than duplicating the drawing part, but this will work for the other chord as well. Now, if I knew that distance, I could use this distance formula to create an equation, and I can actually work out that distance, since effectively what I have here is a right angle triangle. So let me show it to you in isolation. So the triangle here is root 61, the length of my radius, 5, since it was half its chord, and this, which I don't know, but I'm going to call this one D for distance for the moment. Now, I have two sides of a right angle triangle, and I want to find the third, so I have Pythagoras. Here's C, here's A, and here's B. Formula is c squared equals a squared plus b squared. That is root 61 squared is equal to 5 squared plus, I'm going to put in d squared. So 61 equals 25 plus d squared. D squared equals 61, take away 25, that gives us 36, which gives us then the distance here as the square root of 36, which is 6. So now I know that that length there is 6. So the distance from C, 7 minus 8, to the line of the chord, either one, is going to be 6. So that's how I create my equation. Here we need two things. We need the point, and that point is 7 minus 8 because we're going from the center. That's x1, y1. The second then is we need the equation of the line. We worked that out in the previous part. That was mx minus y minus 2 minus 2m equals 0. That's in the form ax plus by plus c equals 0 there. So we get a is, b is, and c is. So a is m, b is minus 1, c is minus 2 minus 2m. So with all of that, I know that when I sub it into the formula, it will equal, it'll equal 6, which is the shortest distance, which we've worked out over here. When I sub in, this is what I get. Remember, those straight lines are absolute value signs. We'll deal with them in a second. Let's expand and simplify where we can. 7m plus 8 minus 2 minus 2m. They're all in absolute value signs all over the square root of m squared plus 1. And that all equals 6. We can tidy it up a little bit more. 7m minus 2m is 5m plus 8 minus 2 is 6. I'm going to multiply both sides by the denominator, so I get 6 square root of m squared plus 1. How we get rid of the absolute value signs and also how we get rid of surds is squaring. So squaring is the best way. We have a few different ways we can work with the modulus. We have a shortcut, but actually squaring is probably the easiest. Remember, when we square modulus signs, we actually do need to square it. nothing cancels. So this is 25m squared plus 60m plus 36 equals. Now, when we square this, we're going to end up squaring both pieces. So it's going to be 36 times m squared plus 1. Cleaning this up a bit more, 35m squared plus 60m plus 36 equals 36m squared plus 36. It's quadratic, so I'm going to bring everything over to one side. So I'm going to take away a 36m squared from both sides. That leaves me the minus 11m squared. The plus 60m, there's nothing that can be done with it. And 36 take away 36 is just a 0. So we have a quadratic, but we don't have a quadratic trinomial. Instead, we have two terms, so we're going to have to factorize in a slightly different way. Highest common factor, m is common in both terms, leaving me with 11m minus 60 equals 0. Zero product property, we let each of these factors equal 0, which means m is either 0 or 11m minus 60 is 0. That means 11m is 60, so therefore m is 60 over 11, which can't be simplified. So now we've got our two values of m. So now we go back and we're going to get our two equations. So equation 1 is where m equals 0. So remember, our formula was mx minus y minus 2 minus 2m equals 0, and we're just subbing in our two values of m. So m equals 0 really means that that line is flat, and it kind of looked like it in the question, but I suppose we didn't know for sure. There was no guarantee that it was exactly flat. So you just have to be very, very careful not to assume anything. Minus y minus 2 times 0 equals 0. We get minus y minus 2, so y is equal to minus 2, and that is our answer. Now, that looks a bit funny because it's not y equals mx plus c, and that's because it's flat, and this is known as a constant. So it is an equation, it's just a different looking equation. Equation 2, we're going to do that when m equals 60 over 11, and we're going to sub in. So we end up with 60 over 11 times x minus y minus 2 times 60 over 11 equals 0. You can multiply across by 11 to get rid of the fraction. That's exactly how I will work. So 11, they cancel, by 11 here, by 11, by 11, and these cancel, and this side by 11, but it's 0. And that gives me then as the second equation 60x minus 11y minus 22, and then minus 120 equals 0, which can be simplified a little bit more. 60x minus 11y minus 142 equals 0, and that's our second equation of the chord, and that will represent this chord here for the line between P and R1. Question 3 was an algebra question which included surd equations, logs, simultaneous equations, modulus, and indices. So part A, solve this equation. It is square root of 2x minus 1 plus the square root of x minus 1, and that equals 5. It says verify your answer. So these are surd equations, or also known as irrational equations. And to do these, we're going to be squaring both sides. But before we can square both sides, it's important to isolate one of them. It doesn't matter which of our surds. It's also important that you verify. This question, again, a mock question, it asks us to verify, but even if they didn't, we would need to sub it back in, because square roots are kind of tricky. They don't accept numbers underneath them if they're negative, especially while we're not in complex number when we're not in complex numbers. So we always have to double check if they're correct. So I'm going to keep this 2x minus 1 over here. I find it helpful if you like close down the square root like this. 5 minus square root of x minus 1. We are then going to square both sides. Left hand side is lovely, that all just cancels. Squared over here, a little bit trickier. So we end up with the first number. I'm going to use shortcut. First number squared, 25, minus 10 square root of x minus 1, and then square the last, so it's going to be plus root x minus 1 squared, which is just x minus 1, because the square root cancels. So now we still have one square root, so we're going to have to isolate that. So I'm going to bring everything, I'm going to bring actually the square root over, so the minus 10 is going to become a plus 10 root x minus 1. I'm going to bring that over. I then had over here x, I take away a 2x. I had 25 minus 1, so I had a 24, and now I'm adding 1 to both sides. So I get 10 root x minus 1, and that equals minus x plus 25. Now you can leave the 10 where it is, or you can bring it across. If you're going to bring it across, you'll have a fraction. If you leave it where it is, you just need to remember to square it as well. So when I square this, the 10 gets squared and the root x minus 1 gets squared. So we have two parts of it, okay? So you end up really with 10 squared and this part squared. They cancel, and the 10 squared gives me 100. Squaring on this side, we end up with x squared minus 50x. And then we have 25 squared, which is plus 625. We now have a quadratic. So I'll multiply out the brackets here on the left, minus 100 x squared minus 50x plus 625. I'm going to bring everything over to the right hand side. So x squared minus 150x. I took away 100x from both sides, and I'm going to add 100 to both sides. So our quadratic is x squared minus 150x plus 725 equals 0. These numbers are quite big. If you're dealing with quite big numbers like this, you can, if you want, play around with it, but minus b is probably the most efficient way to solve this. So minus 150 plus or minus square root minus 150 squared minus 4. A is 1 and C is 725. Let me just write this out in full so we can see it. Okay, so a little bit more space. So x is equal to minus b, so minus 150 plus or minus square root of b squared, so minus 150 squared, use your brackets there, minus 4ac, so minus 4 by 1 by 725 all over 2a, so that's 2 times 1. I'm going to go to my calculator and do the plus part first, so straight into the calculator, getting plus answer, and that's 145. Go back and I'm going to change that plus to a minus, and I get 5. So minus, and that is x equals 5. So now I just need a quick verification. Do they both work? So this is the square root of 2 times 145 minus 1 plus square root 145 minus 1. And I want to see what that equals. It should equal 5. So 2 times 145 minus 1. Make sure you come out of your bracket so that the brackets, keep an eye on what you're typing. With this square roots, it can be a bit painful. So that gives me 29, which does not equal 5. So this answer is not valid. Let's try with x equals 5. So square root of 2 times 5 minus 1 plus square root of 5 minus 1. So that's 10. Square root of 9, that's 3. Plus 4 is 2. And does that equal 5? That does. So therefore that is valid. So our only valid answer is x equals 5. Solve the simultaneous equations given below. So we have two log equations, and I know students can often find log equations quite daunting. So just some tips. Remember, when we're dealing with just log on its own and we have a log button on the calculator, that's really log to base 10. Or common log is what it's known as. How we deal with log equations, whether it's simultaneous or not, is we want to get it as a single log. And the reason we want to get it to the single log is because then we can use our rules to convert it to an index equation. So it's a to the power of x equals y, then log to the base a of y equals x. So it's here on the top of page 21, that little conversion, okay? So that's what we're always aiming towards. So first thing I'm going to do is I'm going to label my two equations. I have equation 1 and I have equation 2. I'm going to start working with equation 1 and I'm going to simplify as much as I can. So I have log of x plus y equals 2 log x. I'm going to bring that over so everything is on one side. So I get log of x plus y minus 2 times log to base x equals 0. Now, preferably I would like to use this little one here, this little rule, which is about when I have two logs to the same base and they're subtracting, but I can't yet because of this 2 in front of my log to base x. What I need to do then is get rid of that, and the rule here, the third rule, will help me do that. And it says when there's a number in front of the log, it can be placed as a power. So then the next line here becomes log of x plus y minus log of x squared equals 0. And now I can go back and apply that second log, which means if I'm subtracting two logs, I can divide. So it becomes x plus y over x squared equals 0. Okay, so you can leave it like this for the moment, or we can convert to an index. So that's going to help us create an equation that's easier to work with. If it's helpful, put in your base 10. I'm going to use my circle method to convert. If you don't want to use your circle method or you don't know it, that's fine. Use your little conversion here. We end up with 10 to the power of 0 equals x plus y over x squared. Anything to the power of 0, and that's actually on the same page, page 21, but you can put it into your calculator either. Anything to the power of 0 is 1, so I get 1 is equal to x plus y over x squared, and then one more go, multiplying both sides by the denominator, we get x squared equals x plus y, and now that equation is much nicer and much easier for us to deal with. Now let's do the same thing for equation 2. Now there are a few different ways, so if you're approaching this slightly different, as long as you're getting the same answer, that's perfect. So here we have a few different logs, so we're going to have to deal with them bit by bit. We have log to base 10 of y, so that's our common log, no base written, is equal to log to base base 10, so it's just log 2 plus log of x minus 1. Now I'm going to use the first law here, the first rule, to combine the right hand side, and that ends up giving me log of 2 times x minus 1. If you want, you can simplify this, and that gives me log of 2x minus 2. I'm then going to bring everything over. Again, it doesn't really matter what way we work it. I'm going to do log to base y minus log to base 10 of y. So log of y minus log of 2x minus 2 equals 0. Combining this using my second law is log y divided by 2x minus 2, and that equals 0. If you want to put in your base here, because we're going to convert it. Okay, if you can't work with the log, we try instead to work with the index, the exponent. So this ends up, again, circle method, or if you prefer, we have our little conversion formula here on page 21 of your log tables. So we end up with 10 to the power of 0 equals y over 2x minus 2. That is the same as 1 equals y over 2x minus 2, which simplifies to 2x minus 2 equals y. What I'm doing there is I'm multiplying both sides by the denominator times 2x minus 2. And that becomes our updated equation 2. So now we have what we know as a nonlinear, linear, simultaneous equations. Here's my nonlinear and the second one is my linear. I'm going to use substitution. My linear has already isolated that y, so I'm going to sub 2 into 1. How that ends up looking is x squared equals x plus, instead of y, I'm putting in 2x minus 2. Tidying this up, I get x squared equals 3x minus 2. Since it's a quadratic, I'm going to bring everything over to one side. I'm then going to factorize using the shortcut for guide number. Minus 2 minus 1 equals 0. And that actually gives me two answers, x equals 2 and x equals 1. I then go back to my linear equation, which is equation 2. And when x equals 2, I then figure out what is y. Remember, the formula is y equals 2x minus 2. So that's 2 times 2 minus 2, which gives 2, which is the 0.22. And then the second point was when x equals 1. So again, y is equal to 2 times 1 minus 2, which gives me 0. So the point is 1, 0. So although it's there are like a lot, that is usually a long simultaneous equation, it was quite straightforward, quite quick to do once you had done the logs piece. So part C. Part 1, solve the equation the absolute value of x plus 2 is equal to absolute value of x minus 13. So modulus or absolute value signs mean whatever is in it, we need to take it as possible, positive. So therefore, in order to solve this, we need to get rid of those modulus signs. And the easiest way to do it is by squaring both sides. We know that when we square both sides, any real number squared is positive. So now we're definitely working with positives, so we no longer need the absolute value signs. So we get x plus 2 in absolute or modulus signs and x minus 13 in absolute value or modulus signs. We're going to square both sides. When we square both sides, you do need to square it. It's not a square root, like, so you're not going to just drop the signs or there's cancelling. You're squaring what's inside. So minus 26x plus 169 when we square 13. There's an x squared on both sides, so taking that away, they'll disappear. So I end up with a linear equation. So I want to get all my letters on one side and all my numbers on the other. So I get 30x, I add 26x to both sides, take away 4, so I get 165. So x is going to be 165 divided by 30. And that gives us 11 over 2 or 5.5, whichever you prefer to work with. Part 2 of this then says, hence solve this modulus equation. So give your answer correct to 3 significant figures. Hence means using what we've just calculated. So it's really important to notice how this equation reflects equation 1, and the only difference is the x is replaced by a 3 to the power of y. So here's what we had in part I. And we worked out that x was 5.5, and then this is what we have now. So hopefully you can spot that the x is now 3 to the power of y. So therefore, where we worked out that x is 5.5, we can now say, well, actually, therefore, 3 to the power of y must be 5.5. Okay, so there was just a substitution there. So what we're being asked to do is to solve for y if 3 to the power of y is equal to 5.5. So we're going to have to use logs here because I have an index equation and I don't know what the power is. I'm going to use my circle method, which is log to base 3 all 5.5 equals y. So y is equal to, going to our calculators, we literally put that in, 5.5. And we want 3 significant figures, so 1.551728585. That's everything that's in my calculator. 3 significant figures means 3 non-zero numbers, so I start with the 1. It's not 3 decimal places, and my next number is 1, so my final answer here for 3 significant figures is 1.55.